Hey everyone, and welcome back to my ROS For Dummies tutorial. Today I'll be covering how to install ROS on your Ubuntu system. So, just kind of coming here to install ROS on your machine. This is just kind of this website that I opened up for installing ROS. Let me see if I can go back. ROS tutorials. No, not this one. ROS installation. Yes. So what you want to do is go to this ROS website called wiki.ros.org/ROS/installation. And as you can see from my last video, you remember how I mentioned that there's 3 versions of ROS that are pretty much common right now. You have ROS Kinetic, ROS Melodic, and ROS Noetic. Notice here how you have long-term support, or what LTS stands for, and it says supported until May 2023. What this means is that, remember that advice I gave you that maybe you shouldn't really download ROS Noetic, or at least the recent version of ROS, because the packages aren't as supported as the version before. This is the latest LTS here, and it says supported until May 2025. Right now, ROS Melodic would just be your best bet. You can try out ROS Noetic, but since this tutorial is for installing Ubuntu 18, or installing ROS on Ubuntu 18, we're going to stick with ROS Melodic for now. On this part of the page here, I have a virtual box set up, and what it is a virtual environment in which you could emulate operating system. You could emulate Windows, for example, or you could emulate Ubuntu or Mac. This is just the easiest way of me installing ROS, because I already have ROS set up on my other system, which is way more powerful than this. So in future tutorials I'll be using that system instead, but for now we're just going to use an emulator. If you want to learn more about installing VirtualBox, I'm going to provide a link down below. It was provided to me by the Robotics and Automation Society from the University of Texas at San Antonio. They're a really awesome organization. I used to be a part of it, and then I got busy with grad school, but they're really cool people, and I really recommend you watch that video if you want to learn how to set up Ubuntu. For those of you that are in my Intro to Robotics course, you don't need to do that. You already have your Raspberry Pi. That's your computer system already, so you don't need to do all this VirtualBox stuff. Your OS is basically the same as this. This is Ubuntu, and on your Pi it's also Ubuntu, so we're going to stick with that. It's similar, it's just configured on different devices. So what we're going to do is just go into this ROS Melodic Marenia tutorial. Remember here how I mentioned that we're going to have different ways of installing ROS? We're going to stick with the Ubuntu version because Debian, that's for Raspberry Pi, but we're going to be using Ubuntu instead. Debian is not something I'm really comfortable using, because Ubuntu would be your best bet and probably with less error configuration. And then there's Windows. We're not going to talk about Windows, so we're going to go to Ubuntu. We're going to set up our sources.list. So this is kind of just how we configure ROS Melodic. There's so many commands, but you don't have to recognize every single one of them. I'll guide you to which one will be useful. So we're going to set up our computer to accept software from the packages.ros.org. This is just ensuring that any package that we put in, it can accept it from this website. I can't copy and paste this over, so what I'm going to do is go to my ROS setup.txt. I'm going to try my best to copy this whole file line. Copy. Okay. It didn't copy everything over, so what I'm going to do is go back up and try to make sure I finish the rest. So that ended at main. And notice how I'm just, I could have just copied and pasted everything, but I didn't, because this is a VirtualBox and it won't really let me transfer from my Windows window to the Ubuntu window. So if you were on an actual Ubuntu system, like installed on your computer as its own separate entity, you could just copy and paste and it'd be perfectly fine. But in this case, I can't really. So that's set up fine. So we're done with this. Then what we're going to do is set up our keys. I never really understood what this does, but all I know is that you just need it. So if you ask me, I'm going to literally tell you I have no clue, just do it. Let me clear, so that way it makes it nicer. Let's go to nano. By the way, don't do what I'm doing here and because if you do it, you're gonna be like, hey, there's nothing popping up. I just put this conveniently for me to just copy the text that I can't copy over here. So if you're on your Raspberry Pi or your Ubuntu system, just go here, highlight it, and copy it and paste it over to terminal. Don't do this ROS setup text. This is just me doing it for convenience. Um, so, alright, let's do this. I'm gonna copy this, even though I won't copy all of it, but that's okay. That's fine. We're gonna do the hard part, which is try to copy this weird number system here. So recognize that key. We're good. If we didn't recognize it, it would have been saying something like unable to import key, which is, you know, this is fine. Or what we just did here too. It didn't recognize it. But this is really important to know. Whenever you're typing something letter by letter, make sure that it's exact. Because if this is not exact at all, you're gonna cause a lot of errors, and it'll be kind of weird to just kind of go through and see, hey, what's missing, and usually it's like a letter or a single number, and it causes issues. So best to do the copy and paste method versus just doing this. But if you can't, just be as careful as possible when typing your stuff. So now we can skip this instruction here. We don't need to use it. Just ignore it. It's not necessary. It's just another option to install. So we're gonna make sure our packages are up to date. So we're gonna do sudo apt update, and you don't have to get familiar with this, but just kind of understand that it's just downloading stuff. This annoying file is fine. I think it has to do with the VirtualBox, but on your installation it should be fine. Next, what we're gonna do is install the actual ROS. So they provide us 4 configurations we can use to download ROS, but we only need to use one. What we're going to install is the desktop full because it provides us ROS, RQT, which just allows us to see the map of our entire ROS system when we set it up. Remember that kind of like map key I showed you in the last video with the PS5 and the ROS setup? This is that RQT visual that allows us to see it, that whole setup. Then we have RViz, which stands for robot visualization, which allows us to simulate our robot and see kind of like its output with the sensors. Generic robot libraries, simulators like Gazebo, and then other perception simulators. So that's it. So we're gonna, all this stuff, this is, you don't need to worry about. So we'll do sudo apt install ROS-melodic desktop full, and then it's gonna install it. And this is gonna take a while, so I'm gonna cut this part of the video, and then I'll get back to you guys soon. Alright, so we're back, and this finished downloading. Next step we're going to do is we're going to do our environment setup. Every time we launch a new shell, for example, if we had ROS on this shell, and ROS on this shell, and ROS on this shell, we want to make sure that ROS is configured throughout every shell, because if not, then we'd have to manually source our shell every time, and it gets super annoying. This is kind of the point of environment setup. We're going to take this command here, this echo, which is taking this command we placed in and putting it in this bashrc file. That way it can just kind of, every time you open a new terminal, it sets up ROS immediately. So we're going to do echo source / opt / ROS / melodic / setup.bash. And then we're going to do squiggly / dot bashrc. Alright. Then we're going to do source / dot bashrc. And yay, it worked. Okay. Next, we can skip this instruction. We don't really need that. We don't need this instruction. And I already installed these packages, but if you want, you can if you guys probably won't have it, so I install them just in case. So what this does is allows us to run the core ROS packages. If we don't have these packages in general, we can't really create and manage our own ROS workspaces. So we definitely need these. So I'm going to type in here sudo apt install python-rosdev python. Make sure you don't type in anything wrong or else it won't install anything, and then you have to start all over again, or you'll have to bring it up in the history and figure out hey, what's missing in one of these commands, and it gets a little annoying. Python-ROS install. Let's generator. Throughout this video, there'll be probably things I'll forget to mention, so I'll probably jump over and say like, hey, don't forget this, or hey, I just realized you have to do this too. So it won't be too out of order. It'll just be little tiny bits of pieces of information that could be like a little bit useful but not necessary. So I already installed these packages, which is fine. What else? What else? Okay, initialize ROS step. So before we can use many ROS tools, you need to initialize ROS step. It just allows you to easily install system dependencies for source you want to compile, and is required to run some core components in ROS. So it's just kind of compilation stuff that you just want to make sure you have installed. Again, you don't have to go too deep into this. I haven't really. It's not really necessary. As long as you just install it, it's fine. I have this installed already, so it's nothing to worry about. Then what we're going to do is ROS step init. These commands here. That's the next step. So we're initialize it. It's going to tell me that I already have a sources file. It won't tell you that. It's because I already had it installed. But it would just tell you like, please use ROS step update. So what we're going to do is ROS step update just to show you. And it'll just update the ROS step. Notice here, there's different versions of ROS that it's skipping and also adding. Like, you notice the first one is Ardent, Bouncy, Crystal, etc. Then we got ROS Kinetic, but it skipped Lunar. And then we have Melodic, Noetic. Noetic being the newest, but it seems like Rolling is now the newest. So yeah, alright. Then that's ROS. That's ROS installed. That's literally the first basic step. Now what we're going to do is try to install and configure the ROS environment. So, blah 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 blah, install ROS, manage your environment. This is a really important command to know. This is print environment grep ROS. This is a special command here, this straight up line. It's usually above your enter key. Unless you have a really weird keyboard, then I can't help you there. But let's see. During the installation of ROS, you're prompted to use source one of several setup sh files or even. So the reason we want to use print environment grep ROS, it's because it allows us to kind of just how do you say it, like fix our system if something goes wrong. So if something goes wrong in our system and it has to do with, like, for example, the ROS master or the version or the Python version, we can use that command to check like what it's connected to. So remember how I mentioned that there's a ROS master, like you could be the master or a Raspberry Pi could be the master. Well, sometimes you need the IP address for that master. The way that works is, let's say you have a master robot and 3 little robots, and you want the 3 little robots to communicate with the ROS master. Well, the little robot will have to get the IP address of the ROS master robot, and you would have to basically copy it and paste it here. Usually you can do that using echo / ROS _ master _ URI, but I'm not going to do that right now because it's really unnecessary right now and I don't need to change it. I'm fine with this computer being my master. ROS version is always 1. We have ROS Python version, which just shows you that it's 2 instead of 3, and so on. This also confirms that we're just on Melodic. Let's see, managing your environment, creating a ROS workspace. So this is important too. Okay. Inside ROS, there's a workspace called Catkin. In this workspace is where you set up your ROS packages. This is where you go to the source folder, put in any package you want, such as like a sonar package, a LiDAR package, a camera package, whatever it may be. And that's where you configure it so that way ROS can take these packages and have them work together as a whole. So what we're going to do is, make sure we're in our home directory, and we're going to make a directory, and it's going to be called Catkin. And we're going to add src. Fix it like this. There we go. And what this is doing is making a directory catkin _ workspace with a source directory inside too. We're going to do cd catkin _ workspace. We're going to press ls, and it shows our source directory here. As the instructions say, we're going to cd in the catkin like we just did here, and we're gonna do catkin underscore make. And what this is gonna do is build our packages for ROS. Um, it just configures the catkin workspace. That's all it is, and it'll add some special folders in here. And it says if you look in your current directory, you'll now have a build and devel folder. Inside the devel folder, you can see that there are now several setup.sh files. So if we go in there, we have sh files. That just stands for shell, and we'll go back to that later. It's a long explanation that we could cover in another video. To understand more about this, you can just read this catkin directory here. And we're going to source our development. So this is a very important command you have to always keep in mind, because if you open a new window and you started using commands like, I don't know, ROS run like arviz, it won't recognize it. Well, one, because the ROS master isn't communicating, and two, if you wanted to like tab arviz and complete with another, oh, I guess it did it, but never mind, whatever. It's just very important to do. Just always do it in every terminal. So like source, but you have to make sure you're in the catkin directory when you do it. So you do source devel setup.bash, and it'll just make sure everything's set up. Or you can go to your /bashrc, and you can put it here too. And source your stuff. Then we just want to double check to make sure our ROS package path is correct. So it's going to be home, your username here, catkin workspace source, opt-ROS, and then this is going to be melodic instead of kinetic, and then /share. I'm going to do this. And it shows our home, our username here, and then melodic. Alright. And that's the gist of it. That's the basic ROS setup. But I just want to say, this is very important to understand to go through the ROS tutorials, because there's a lot of information to cover here, like how to create a ROS package, how to build a ROS package, learn how to communicate between different devices using a publisher and subscriber. A lot of important stuff. So the best way to learn ROS, I say, is kind of on your own, because it's probably the best experience, honestly, if you just learn it on your own. But if you ever need help, I mean, feel free to consult me, like via the chat, or send me a message, tag me. But you always want to read these tutorials. If you're confused about how to create a ROS package, don't ask someone. Just go here to create a ROS package and just look at it. If you feel even more confused, at least show that you are trying, and then show the information to whoever you're talking to for help. Like, hey, I understand this, but I don't understand this part of like creating a catkin package. It's all about trying. That's what ROS is. It's just experimental. What I can show you here is just a demo of how ROS works, because I don't want to make this video too long, but let's every time you have like a ROS setup, you're gonna need different terminals to configure each ROS setup. So what we're gonna do is call ROS core, which means we're gonna set up our master on this terminal. And if we do something called ROS topic list, we can see that there's topics placed here, and those topics relate to the ROS core master here. But let's say we didn't have ROS core set up. Let me kill it real quick. And I do ROS topic list. It'll show unable to communicate with master. So anytime you have a ROS setup, make sure you have a window with ROS core in it. So that way it sees that it's a master and it's communicating with it. And then we go back to ROS topic list, we see those topics published again. This VirtualBox isn't very powerful, so it's going to be really rough to show you RViz on this, but I'll show you on the next video just kind of like what it looks like in a more powerful system. But let me show you ROS run RViz. Yeah, it's really tiny, so it's a really terrible way to show you guys. It's going to be a little bit of a mess. See, it's so tiny I can't even like interact with it. but you can see kind of part of it. So this is RViz. Honestly, let me just kill it. Kill it with fire. Alright. Kill it with XC. Let's try it again. Can we move it? No, we can't. Anyways, I'll just show you sketches of it. I don't know why I said sketches. Okay. So, all this is a robot simulation. We just kind of try to eyeball it as best as we can. This is where you would set up your robot here, like a robot model, and you can like output sensor displays. It's just a simulation, visual like simulator. Just helps you see what's going on with your robot. You have like a map frame. You have a global status, like a fixed frame to set up your robots. I can't come down here, but you can actually add sensors into here, and if you have like a LiDAR setup for ROS, it'll publish a scan topic, and you can add the scan portion here, and it'll show you the actual like LiDAR scans it's receiving in the real world to here, and it's really awesome. I can't show it right now because I just don't have. Oh, okay, now it maximized in a way, but yeah, it'll show you various tools you can use. You can have like a camera. You can show depth cloud, which is like depth perception if you have a special depth camera. Grid cells for navigation. Let's see. Image for outputting your camera image or video stream. Laser scan, map if you're mapping, markers, marker arrays, odometry, point clouds, polygons, poses. The robot model, if you make a model in URDF, which I'll show you guys probably in the next video, which would be a best start. Show you that, the frames of that robot model, temperature, IMU, all that stuff. It's really cool. It's a really useful simulator. Let me minimize this here, and this is where your stuff would be simulated if set up right. So that's the end of this video, and let me know what you guys need. If you guys have any questions or want me to cover other stuff, definitely look at this website, the ROS Wiki tutorials, after you're done setting it up, because there's so much you can do with it, but I really feel it best if you guys just kind of look through it and kind of just learn on your own or experiment. Learn how to read errors, learn how to Google errors. That's just the best way to do it. Subscribe to my channel and let me know what else you want. I can never do this right. Usually YouTubers do it so easily. But yeah, subscribe, smash that like button, and turn on bell notifications to know when I post my next video. And thanks for watching.